Me again, Mr. C from room 355. And you guys, part 2 on this topic 9, which also leads into topic 10, because topic 9 is about erosion and topic 10 is about deposition, which is the stuff left after erosion. All right, we started off with weathering. Weathering leads to erosion. What's the big diff? The big difference is weathering is in place. Once again, physical and chemical weathering producing the end result of soil. When stuff gets moved, it becomes part of the erosional system. Got it? Good. First thing we're going to pick on is running water. There's running water right there in this valley. Notice that the valley, because the letter V, has a V shape. You might recall that contour lines, as they cross a valley, cross a stream, I should say, make a V shape. Why do they make the V shape, those contour lines, when they cross a stream? Because streams flow through valleys, and valleys have a V shape. See, it all works together. And those contour V's point uphill on a contour map. But that was way back in topic 2. But this is topic 9. There's our stream. Now, streams tear up the ground. You guys think streams, I want you to think one thing. I want you to think water slide. That's it. That's the whole unit right there on streams. Water slide. Now, if you've never been on a water slide, I feel bad for you. You should have been on a water slide by this point in your life. Okay? So, what happens with a water slide? Where does it go the fastest? Well, a water slide goes the fastest when it's the steepest. Where else does it change its speed? It changes its speed around the curves. Okay, and where does it go the fastest? Hello? It goes the fastest on the outside curve. That's why they make a big bank on the outside of the curve. Otherwise, you're going to fly out. It's really bad for business when you go flying out and end up in somebody's driveway. Okay, it's much better to keep you in the slide. Now, if you had a whole bunch of rocks in your hands and stuff that could scrape up that slide, where's it going to get scraped up? It's going to get scraped up on the outside curve. And if you lost your mat, where would it end up? It would end up on the inside of the curve. You know what? I'm talking about this. Let me show you what I mean. Okay, as far as streams go, what do you have to know? You guys got to know this. You guys have to know this. And if you know this, you know everything there is to know about streams. Really, I'm telling you. Okay, first of all, where does a stream have its greatest potential to start doing its stuff? Where do we all have our greatest potential? In the beginning, when we're first born. Okay, that's when you have your greatest potential. You might screw up your life after that, but when you're first born, you start off with great potential. Well, streams start off with great potential right here. And the higher a stream starts off, the more potential it has to rip up the ground. So a stream like the Ganges, which starts in the Himalayan mountain range, has a greater potential to rip up the ground than the Niagara River. But the Niagara River's much lower, much shorter. The Niagara River is also much faster. See, that means it's turning into kinetic energy. So kinetic energy is the actual movement. Potential energy is the potential to have that movement. In a water slide, the water slide that has the greatest potential starts up the highest. Is it going to be steep, or is it going to be gentle on the way down? If it's gentle on the way down, not too much of that potential, or I should say, the potential will be slowly converted to kinetic. However, if it's steep, like one of those things where you're going to lose your shorts, okay, or they're going to end up, and you're going to end up talking differently when you get to the bottom, that is where it's changed into kinetic energy right away. So I check out this stream. This is an airplane view, and this is a side view. See, this is not up, and this is not down. This whole thing is on the ground. It does happen to be up and down, but this is the side view. So this isn't a hill, this is a curve. We call that curve a meander. Now, where's the water going the fastest? You got to look at the side view for that. And where's it going the fastest is right here. So that's where it's going to have its greatest kinetic energy. That's where it's going the fastest. And that's where it's going to be tearing it up, man. Okay, now it's going to go around the curve at 2-3. I can't see that from the side. I can see that from the top. And where's my speed going to take me? Well, if there wasn't a high wall, my speed would take me out in the parking lot. But there's a high wall, so my speed is going to take me crashing along that outside curve. So the outside curve is going to have the erosion. The inside curve might collect a few mats. And if this is a stream it's going to collect sediment because that's where the water is going to be going slower, and that's called deposition. I'll just say dep right there. Okay, so we got erosion on the outside, deposition on the inside. So right here, what's going to happen? Which side is going to be the side of erosion? Tell me. That's right. It's number 6. 6 has the erosion. 5 is going to have the deposition. What about right there? Yep, it's going to be 8. Were you wrong? Hopefully you weren't. 8 is the erosion. D is the deposition. Now, I've seen this with my little day campers. They'll lose their mats on the way down, and sometimes they'll get stuck on the inside curves because that's where you have the least amount of water. However, at the end of the day, where do all the mats end up? At the end of the day, they're all going to get flushed out. So they're all going to end up at the bottom. And what's going to happen is they're all going to deposit there. So this is the site of the most deposition. Now I've watched this, and if you have big kids, bigger than my little day campers, like my little 6-year-olds, the big kids, when they get down to the bottom of the slide, man, they hit the bottom right away. They lose their mat, they go right down. Some of my little day campers, my little 6-year-olds, they just keep skimming on the top of the water. That's true with sediment. With sediment, what's going to happen is all the sediment, when it hits a larger body of water like this ocean, this is like the Mississippi dumping into the ocean, you're going to get the big particles, and then the medium ones, and then the small ones, and then even smaller. Well, on page 6 of your reference table, it's going to show that these might be pebbles, and then you're going to have sand, and then you're going to have silt, and then you're going to have clay, and then even further out, we're going to have sediment particles, rocks called evaporites. Talk about that later. So, that's where the deposition is going to happen, that's where the erosion is going to happen. Now, what does the shape of the valley of this stream look like as you go through it? As you're going down through this water slide, what does the shape of the actual channel of the water slide look like? Well, if you're going around, let's pick 8 to 9. In fact, 8 is the north side of this diagram. So here we're going to have what's called a profile. What we say is the outside curve is steep and deep. So if this is the water, and this is the channel, because when a stream's going straight, it looks just like a V. But what's going to happen is the outside, if this is the north side at 8, and this is the south side, it's going to be steep at 8, and it's going to be gentle as we go towards the south side. Now, I know this is a little strange. This is you going through the tube of the water slide. You're coming around the bank, and the outside of the curve at position 8, which is the north side, is going to be steep. Otherwise, you're going to go flying out. Now, you wouldn't have that much water. The water would be down here. But the shape of the valley is what we're looking at here. The outside curve is steep and deep. Now, what about the sediment itself? Well, the sediment itself might start off big and chunky, like this. It might start off big and chunky, okay? Very angular, very big, very clouded. There's this place in New Jersey. It's called Cape May. And along New Jersey, after millions of years of tearing up pieces of quartz by tumbling it out in the ocean and streams that put it there, the quartz ends up, I'll put it in the light, like this little piece right here after years and years of tumbling. So what happens is that something that starts off very angular turns out to be smaller, rounder, and smoother. In this case, even clearer. That's not always true. Okay? And that's what happens to particles in the erosional system. Then how do they deposit? Well, we talked about that a little bit. They horizontally deposit from big to medium to small. They also vertically deposit. And usually what's going to end up landing first? This makes sense. The big stuff. And then the medium stuff, and then the small stuff. How could a smaller piece, though, end up settling big faster with less time than a big piece? It could be more dense. Let's say it's a really heavy material. It'll settle right away. Okay, so density has something to do with it. And let's say all the pieces are the same size. All the pieces are the same size. Then they would settle by their density. And then also, shape is a big deal too. So, particles depositing, particles in an erosional depositional system with this stream are all part of this next chapter of topic 9.